Good. Now we are about to have a talk by Omar Galeano and Kudo. The title is Modern Agile Delivery, Building with Quality and Velocity at Scale. Please take it away.
Well, thank you everybody for joining the session on Modern Agile Delivery, how Slalom builds quality and velocity at scale. My name is Omar Galeano. I lead the quality engineering team.
My name is Kudo. I'm senior quality engineer.
And Slalom is a business and technology consulting company. We have over 12,000 people in 8 countries worldwide. And what makes us unique is our collaborative approach to consulting. We view our clients as not just customers, but partners. So what we'd like to do in this session is give an overview of what we're calling modern agile delivery. And then we'd like to jump into a case study with a client that we did here in Japan, JRCS. And finally, we'll leave some time at the end for Q&A. And some questions that we'd like to address along the way include, are hardware and software quality the same? What is the true indicator of software quality? How do project teams collaborate? How can we reduce risk in our releases and deliver with velocity and have confidence in our releases as we scale and evaluate the quality of machine learning features? And we're going to move fast. So feel free to review the slides after the session, and we'll also leave some time for Q&A afterwards.
Let me just take it out. Okay, so before going into details, I'd like to start with a question. What is quality? So quality is such a broad term. So it can mean different things to different person. So it is critical for us to align on this first. So we'd like to use this one from James Bagg and Michael Bolton. Quality is value to some person at some time who matters. Okay, so when we think about quality of hardware like nuts and bolts, so it is often about meeting requirements or not. But software has different quality needs. The requirements for software is less tangible, and user experience is very important, and development processes are variable, and quality control measures are less standardized. And as software becomes a critical part of business, this has become more and more the case. Also, there can be an assumption that comprehensive waterfall QA processes can deliver a better quality than Agile. But for projects where requirements are less clear or likely to change during delivery, an Agile quality approach can often deliver better outcomes. At Slalom, we call it quality engineering. Or another way to put it is quality engineering is how we incorporate a focus on quality into modern Agile software development. And it is how we bring a modern team-based approach to testing software and data services. Now, let's talk about quality engineers and their skill set. So we have a specialist role called quality engineer. And this picture shows the quality engineering learning roadmap, which was created by one of the quality engineers at Slalom. And these skills ranges from computer science basics and quality assurance fundamentals to things like latest automation framework and application stacks and testing tools. And as you can see, it is quite like huge, and some people might be overwhelmed by this, but the important thing here is that, so first, quality engineers depend on wide range of skills, and we should be aware of that. But the second, these are really huge, but no one person initially has all the skills that on the list, but it just indicates that we as a quality engineers are lifelong learners. So now let's look at our QE core principles. For all projects, we follow these QE core principles. Our core principles empower our QE team members to have conversations and establish behaviors and set assumptions, so set expectations that promote Agile concepts. And these are the four. The first is a whole team ownership of quality. And second, empowering teams by bringing focus on quality. And third, close proximity between development and test activities. And last one is automation is critical. And these core principles unlock the power of shift left. So as you can see here, the cost increases as the timing of catching bugs becomes late. And idea here is that identifying bugs later in the phase can increase the time and financial cost of fixes. So here is a scenario that a bug discovered in later phases like integration testing phase. As you can see, it requires many more steps to solve the issue, resulting in costing developers more time to fix. So here's another scenario that the same bug found early phase, like during local testing by a developer or quality engineer. And as you can see, it requires less steps, meaning that the team and the developer can spend like less time on the solving the issue. The last scenario here is that when we find a bug early in the phase, like sprint planning as a missing requirement, and it's even requires less steps. And since any development work hasn't been done yet, the team can just update the requirements, resulting in minimum cost. So another role of QE is to create quality strategy and align that with the team. And we make it intentionally high level and collaboratively execute as a team. And it includes things like types of tests and test automation framework comparison and quality metrics we want to follow. And also how we want to manage our defects and trace them. And it is not one-time event or fixed thing. Quality strategy will be adjusted as the project proceeds. So here, let me share how a team can collaborate on quality activities. So as you can see here, some quality activities are driven by quality engineers, and others are driven by other roles, such as developers, and quality engineers would be supporting them. And this collaboration would vary from team to team based on factors such as each member's skill set and dev to QE ratio, and so on. The important thing here is that they work on these activities collaboratively as a team.
Now, modern software is complex, and often it's comprised of many layers. And the quality of one layer has the potential to impact the quality of all the layers above it, leading up to the customer experience. So at the end of the day, the true barometer of quality is the customer experience. Everything else serves that. But measuring software quality is hard. And traditional waterfall metrics are concerned with managing things like test cases, requirements, defects. Whereas quality engineering is about preventing defects in the first place with minimal management. So we try to focus on customer-centric metrics, things that actually impact the customer or the delivery of value. Now, as far as quality strategy, this also includes our test automation strategy. We like the test automation pyramid as a metaphor for greenfield development to deliver fast, reliable test automation, where we have unit tests at the bottom. They run fast. There's a lot of them. On the top of the pyramid, we have UI journey tests, which resemble the user. And then in the middle, we have integration tests, which are a balance of speed and coverage and reliability. Now, the reason that we do automated testing is because we want to ensure that features that were working in the past are still working in the future. And we call this regression testing. Without it, the time that it takes to do manual regression testing grows sprint over sprint. In this example here, you can see that by sprint 9, 94% of our testing time is just on regression. Now, if this pattern continues, it can take days, if not weeks, to complete manual regression testing. Whereas automated tests can run in hours, if not minutes. Now, test automation has some upfront investment required to build or buy a framework, create tests. And so it may be necessary to convince a stakeholder to invest in it. So one way to do this is to say that test automation reduces the time it takes to manually regression test and increases test coverage. So every time test automation is run, cost savings increases. And eventually a break-even point is reached when positive ROI is achieved from that point forward. Now, as software scales, it can become increasingly difficult to release with confidence. So to manage scale, we build test activities in every phase of our pipeline so that as the code progresses towards production, our confidence in the quality of the code increases. And nowadays, low-code and no-code test automation tools are becoming incredibly popular, especially here in Japan. Now, historically, we haven't really recommended these tools because we like the flexibility that we get from coding, and we don't want to create gaps between development and testing activities. That said, we understand that some clients can do very well with these tools, and that manufacturers are working very hard to close those gaps. So there may come a time when we make the leap, but we're not quite there yet. And performance testing can help us to identify latencies and downtimes due to user and data load. But what often happens is testing is delayed until right before release, and there's no time to complete testing, or I'm sorry, there's no time to fix the bugs that are found by testing. So what we recommend is plan for performance testing early, integrate it with the build pipeline, and tailor your approach to your solution. Now, it's possible to have a great test automation suite and deliver a poor customer experience because of data quality issues. These can be some of the most difficult issues to find because all the automated tests passed. One example is the Zengin banking system failure here in Japan last year, where over 1 million bank transactions were delayed. In this case, thousands of application tests passed, but the root cause was corrupted data. So at Slalom, our quality engineers work closely with data engineers to provide unit testing and exploratory testing on source and production data. And we use tools like PyTest, Great Expectations, and Pandas profiling. And speaking of data, when testing machine learning features, the model is only as good as the data that trains it. And quality can be measured through model evaluation and model testing. Model evaluation evaluates the quality in terms of traditional statistics like accuracy, precision, area under the curve. Model testing gives additional insights through unit and functional testing. Now, since model training can be extremely expensive, it's a good practice to do a lot of your testing on a model trained by a small subset of your data to find the major features, then go back and test the fully trained model. Now, recently, with the release of large language models like ChatGPT, LLM quality has become a big topic. And these can be really difficult to evaluate because you have a lack of oracle and hallucinations and ethical issues. So Slalom has created a working group between quality engineers, data engineers, machine learning engineers to create best practices on our approach to LLM quality. And we're making good strides here, but it's definitely a work in progress. Okay, so now we want to change gears and share a case study on an actual project that we worked on with a client here, JRCS. Japan's maritime industry is facing a crew shortage due to the decreasing population and people choosing careers elsewhere. So JRCS came to Slalom for help in achieving their dream of autonomous shipping. And our first step was to create a decision support application for sea captains. They also needed help in developing their digital innovation group that they created. So by working together as one team, led by Slalom, they could learn our process and eventually take over the project as Slalom rolled off. So JRCS engineers came to Seattle to work together. And the team was ready to build. And then all of a sudden, COVID hit. And JRCS had to go back to Japan. So we reconfigured our team using our global network in Australia and created a distributed team working across time zones. Slalom had QEs in the United States and in Australia. And a software engineer in Japan from JRCS was mentored to play the QE role.
Okay, let me now take over what we did during the project. So we created our quality engineering strategy first, which included things like types of tests and test automation framework comparison, and also quality metrics we plan to follow, and the defect, so how we wanted to manage our defects and triage those defects. And we made it high level and made it as a living document that evolved as we progressed. Of course, there was a test automation part included. And here is an example of UI automated test. And for this project, we decided to create our own UI automation framework, which were based on Unity unit testing framework. And the reason for that was, in that way, we could write the test code with the same language as the application code. And that enabled us to create many test cases quickly. And there was a great collaboration between quality engineers and solution architects working together, creating this test automation framework. And in the end of the phase, they had about 100 UI journey tests running reliably. So here is so let me share how our QEs worked with the team during a typical 2-week sprint. So during each 2-week sprint, quality engineer worked closely with the team members to execute the quality strategy. So I will go through what they did really quickly. So starting with reviewing backlog items, our QE provided initial estimates from testing perspectives and also reviewed acceptance criteria. And also quality engineer was involved in sprint planning as well. So they raised risk areas for committed stories and also reviewed sprint goals. So before work for each story started, quality engineer had a session with developers to discuss things like, so what to test for the story and which test to automate in which layers. And that was a collaborative activity between quality engineer and developers. And while the story was in development, the quality engineer would start writing test code, such as API tests and performance tests and journey test scaffolding. And they also assisted developers to write unit tests. And as you can see here, the story development and test development were happening concurrently. So quality engineers also contributed to code review. So they reviewed testability of the code and also reviewed unit tests that produced by the developers. So once a build has been deployed to integrated environment, quality engineer would run automated integration and journey tests and also conducted non-functional tests as well, such as performance testing. So when the developers and quality engineers were ready, so they would have a desk check session. And sometimes they included experienced designer for the session as well. And they would, during the session, they would walk through the story and did final exploratory testing together. And after the desk check has been done, a story would be reviewed by product owner for acceptance. And here again, quality engineer would did play a role in demoing individual stories and also reported some quality related metrics to the PO. So at the end of each sprint, all completed stories are reviewed with the team and other stakeholders. And QE also played a role in demonstrating features and test automation, and also they shared some key quality metrics with the team. So finally, during the sprint retrospective, QA contributed by highlighting concerns that impacted quality and also evangelize ideas to improve delivery. And I went through really quickly, but I hope you get an idea of how QE worked with the team. And I guess collaboration continues.
Yeah, so when building machine learning features, the stories were treated no differently than any other story. So QEs and ML engineers would come together, review the story, figure out how to evaluate quality for that story. Now, in some stories, for example, we have camera calibration. We took a quantitative approach using OpenCV's reprojection error metric. Other stories, like automated bounding boxes, we took more of a qualitative approach, making visual inspections against some defined quality scale. As for unit acceptance testing, user acceptance testing, the boat that you see here, the Hankyu Ferry, was our UET environment, and it hosted our hardware. The ship's captain and crew were our testers, and our quality engineer in Japan rode along with them and had them use the application on an iPad, collecting feedback and making observations. So after about 9 months, JRCS was able to take over the project and Slalom rolled off. About 18 months later, this video was broadcast on the news featuring a trial run of an autonomous boat that JRCS was a part of, which included our software. Here you can see the boat is getting ready to get started. Now it's traveling 2 kilometers around the bay. Visual data is being fed in through the ship's cameras. Processed by electronics. And the ship's coming back home, no incidents. And then pulling back in and comes to a stop. And this photo is from just this past Friday at Sea Japan here in Tokyo, where JRCS was demoing the product that we built together. They have not only gotten sales in Japan, but a lot of interest from Europe as well. And their digital innovation group has grown from 15 people to 40 people. And Slalom and JRCS remain great friends. Thank you. So some key takeaways. Hardware and software have differing quality needs and measures. Customer experience is the true barometer of quality. Quality engineering is a collaborative whole team effort. Shift left pays down technical debt early to reduce risk. Automated regression testing enables long-term velocity. Testing throughout the CI/CD pipeline builds release confidence at scale. And an application or ML model is only as good as the data that feeds it. So now we'll open up for any questions. Thank you. All right, if there's no questions, then we'll wrap up. Thanks all.
Thank you. Thank you having a presentation. If you have any question after this, please contact them. They will join networking party. If you join networking party, then maybe you can ask them. Thank you.
The next presentation will be from 5 p.m. So we have another break until then. Thank you very much.